Hello everyone, welcome to my programming club. Today we'll be solving another daily lead code challenge, and the challenge name is combinations. So the challenge statement is like this: given two integers n and k, return all the possible combinations of k numbers chosen from the range 1 to n. You may return the answer in any order. So what the problem statement is saying, you will be given a range 1 to n, and you have to make a k-digit combination. K-digit combination. So to make a k-digit combination, you have to make choices these numbers, and accordingly the combinations will be formed. Choices among these numbers. This is the given range. Now, the thing to be noted is when you will be forming the combinations, for example, these two combinations 1 comma 2, here k was 2 and n was 4. So you were having choices from 1 to 4, and you will have to form uh, two digit combinations. If you form a combination 1 comma 2 and you form another combination 2 comma 1, these two are the same thing, since order does not matter. Also, it is to be noted that duplicates here are not allowed. Duplicates not allowed. Since in combination by default the duplicates are not allowed unless otherwise stated in the problem. So I hope it's clear to you. Now let's move to the constants part. What are the constants? N's size is here given to be of order 20. So n size is of order 20, and k is either lesser than n or equal to n. These are the constants. Let me quickly change the color. So these are the constants. You have to form k-digit combinations from this given range. Now what will be the brute force way to solve this? What will be the brute force way? Now when you will be generating all the combinations, let's say this is the given range n to 1 to n, and this is the final combination that you have to make, k-digit combination that you have to make from this range. So each of the number in this range will be having two choices. Either that number will be included in the final combination. In this combination, either that number will be included or not included. So two choices. So for each of these numbers will be having two choices. So it will be like this. It will be n times. what is 2 raised to power? It will time complexity will be 2 raised to power n of this brute force approach, and n here is 20. 2 raised to power 20. Let's check what 2 raised to power 20 is. This number 1048576. So 2 raised to power 20 is 1048576. So this is the number. Now it is lesser than 10 raised to power 8 operations, since its magnitude is of the order 10 raised to power 7. So those of you who are not familiar with, let me quickly change the slide, who are not familiar with how the time complexity of accepted solution varies according to input size. I'll provide a link for an article describing this. You can check that link, that article, explore that article, and come back to the solution. At now, what I can tell is, in 1 second, you are allowed only 10 raised to power 8 operations. So, your order for your solution to be accepted, it should be lesser than 10 raised to power 8 operations. Otherwise, you may get a TLE. So this will not give us TLE. Solution will be accepted. But how will we keeping track that there are two uh, trickier parts in this solution? How will we keeping number one, we keeping track of already included numbers. Since duplicates are not allowed, duplicates are not allowed. Already included numbers in combination. We will be forming combinations in this direction, left to right. We will be keeping track of, let me quickly change the color, keeping track of already included numbers in combination. Duplicates are not allowed. So this is one thing. Another is, since the order does not matter, if this is the only thing. Since the order does not matter, if there are no duplicates, your order will be the same. So if, let's say, already included, if you try to include it again, it will not should not be allowed. And you have to also, you have to this second condition will be, you have to check uh, whether this type of conditions should not occur. These two combinations will be the same thing. So the ordering of combination, you have also to also check the ordering of combinations. Only since ordering is not mattering, if a number is included in the combination, you should not consider it again in the combination. So how will you be keeping check of this now? Now, if you see the constraints, carefully observe them. N size is here 20 only, and K is maximum size is also 20. So in order to store a k-digit combination, store it. How will be storing it? If somehow we can check in of one time that whether a number is included or not, number included or not, in combination. and this should be our concern. So what we will be doing is we'll be storing the combination in an integer variable. Since an integer variable is of 32 bit, these will be the 32 bits. Now each of these bits can represent a digit in combination. So we will be only required 20 bits. Let me quickly change the color. 20 bits only be required out of 32 bits to store the combinations. Max. This is the maximum value of k. So at max, 20 digit combinations will be made. 20 digit combinations. So these combinations will be in the range 1 to 2 raised to power 20. If you consider, uh, this will be the range 1 to 2 raised to power 20. The numbers from 1 to 2 raised to power 20 can represent combination states, combinations, or say combinations. Let's call them states. Different combinations, we are calling them states. So numbers from 1 to 2 raised to power 20 will represent them, which is nothing but what we have to do is we will check for numbers from 1 to 2 raised to power 20, and if, let me quickly take another slide. We will check from numbers from 1 raised to power 1 to 2 raised to power 20, and if the number of set bits in these numbers happens to be equal to k, is equal to k, then it is the combination we are looking for, k digit combination. Then it is indeed the k digit combination we are looking for. We're counting the number of set bits. What are the set bits? In integer variable is of 32 bits. So we're counting the number of bit sets out of these 32 bits. And if they happens to be equal to k, so it will represent a k digit combination. I hope it's clear to you. Why will it will fit in a number? Because we for each number we were having two choices, and such at max 20 numbers were possible since n size was 20, so 2 raised to power 20, and thus we are iterating from this range 1 to 2 raised to power 20. And you may ask, okay, we will know if a number is representing a valid combination, a valid k digit combination, but how will we forming that k digit combination from that number? How to convert uh, representation number, let's call it representation number to k digit combination. This will be your next portion. So what you will be doing, you will be using bit manipulation to check which bit is set. You will take a variable num and initialize it to 0 because the range is from 0 to n. Okay, and then what you will do is you will keep on uh, iterating over the digits of that number, that is representing number, till there are no set bits. Over this representing number from right to left, from the least significant digit to most significant bit. Sorry, I called it digit, it's bit. From the least significant bit to most significant bit. So this is what we'll be doing. And as soon as we found a match, that let's say this was the number, and here num value was 1, and this was the what it is the second bit, or say the first bit, this was the 0th bit, and here n's value would be 2. Now say this bit is set, then you will include 2 in your combination. Now let's say you encounter 5 was the num's value here, and this bit was set, so we will add 5 to your combination. So in that way you will be converting this representing number to combinations. So I hope it's clear to you. If it's still not clear to you, it will be more clear to you in the coding part. Now let's quickly move to the coding part. What we have done is we are checking from 1 to 2 raised to power 20. So this will the maximum states. If state is nothing but state is a combination of digits. State is nothing but a combination of digits, and if this combination is representing a k digit combination, then we will consider it. We will be checking if this is representing a k digit combination. The number of set bits will be k. Number of set bits check. If it happens to be equal to k, then it is indeed the k digit combination that we are looking for, and we will convert it into a list or say combination. This will convert the state into a combination in form of list. What we are doing is we are iterating from the 0th bit to the nth bit, from right to left, and at each iteration we are increasing the value of num, and if the current bit happens to be a set bit, we are adding num's current value to our combination, and at last we will be adding that combination to our answer, and we will be returning our answer. So this wraps up the solution of the today's Leetcode challenge. Thank you for watching. Thank you. If you have any doubts, you may ask them in the comment section. Thanks.